Hi there. Today we're going to look at solving equations, and we're going to start with solving one-step equations. But before we start, there's two things that I want you to commit to memory. The first one, before we even do any work, I want you to write this down. Okay, so in a learning bubble, we're going to write, always use the balancing method. When solving equations. Okay, so that is your first learning point of the day. I'm going to put mine in a little learning bubble here. Always use the balancing method when solving equations. And I want a second learning point here before we've even started. And my second point is always check your answer using substitution. Okay, always check your answer using substitution. That is my second learning bubble. So please commit those two things to memory, even though sometimes I know you don't want to. And probably with the first couple of questions, you're not going to want to use these methods. I really want you to bear with me. Okay, so my first question, we're going to start nice and easy. X plus 4 equals 7. Now, I'm sure many of you will be shouting out, Miss, the answer's 3. I don't need to use the balancing method. Okay, but we're going to copy it down and you're going to see why in a moment. Okay. So for this one, remember with the balancing method, we do the same to both sides. Whatever I do to this left-hand side, I need to do exactly the same to the right-hand side. So I've subtracted 4 from both sides. That means I've now just got X on its own on the left, and I've got 3. But you knew that because it was easy. Because actually what you did, you used this second learning bubble, checking using substitution to see that something plus 4 equals 7. So actually what you did was a little bit the step I want you to use for checking, okay? So let's try. Check using substitution. So I'm now going to substitute my X for 3. So I've got 3 plus 4 equals 7. You don't need me, you can mark your own work, okay? Too easy. You're still going to humour me with this second one, and you're going to see why in a moment. Okay, so for my second one, I'm going to do X subtract 7 equals 11. Again, some of you are probably already shouting out, we know the answer's 18, Miss, we don't need to show all this working. But you're going to humour me and you're going to write it down. We're going to add 7 to both sides. I know that now on my left-hand side, I've just got X. On the right-hand side, I've got 18. I'm going to check using substitution. Okay, so I'm going to take my 18, I'm going to put it into my equation. So I have 18 subtract 7 equals 11. I know I've got the correct answer. I'm just also going to underline my answer to make it nice and easy for marking and any correction purposes. All right, so why do I want you to do this method and only this method? So let's have a look. Okay, why the balancing method? Well, what about this question? How would you solve this? Let's have a look and see. So I'm going to say, this is going to be my question 3. I've got 7x plus 4 equals 21. Okay? All right, how am I going to do it? Do I use a bit of substitution? Okay, let's say x was 1. 7 plus 4, that gives me 13. That doesn't work. Hold on. What if x was 2? 7 multiplied 2 is 14. 14 plus 4 is 18, not 21. Maybe it must be 3 then, yeah? Okay, so 7 multiplied by 3 is 21. So it gets tricky if my solution is not a whole number. It's not always going to be a whole number, and it's not always going to be positive. So please, however easy question 1 and 2 may have been, please get into the habit of using the balancing method, because otherwise you're going to come to a question like this and you're not going to be able to do it. I'm not going to answer that now. I'm going to come back to that one, and then you're going to have to tell me off if I forget. I'm just going to write it down here so I don't forget. If I forget, it'll be embarrassing, won't it? I'll have to go back and re-record this. So we're going to come back to that one. I'm going to show you later. I'm going to leave that as a little teaser. Okay, so let's move on. We're going to do question 4, which is 5x equals 20. Now, some of you will have heard this in the classroom, if I teach you, that if you wanted to buy Mrs. Sparks a really, really nice box of chocolates for Christmas, and you could buy 5 boxes of chocolates for £20, how much would 1 box of chocolates cost? They're really posh chocolates. Okay, so to work that out, we need to divide both sides by 5. I know that 5 lots of x is 20. I don't want 5 lots, I just want 1 lot. So I'm dividing both sides by 5. So I've got x on the left-hand side. 20 divided by 5 gives me 4. I want to check using substitution. It's the last time I'm going to write it out in full, otherwise we'll be here all day. I'm going to check using substitution. So I have 5. Now remember, when you write 5x, it's 5 lots of x. There's a little invisible multiplication sign between the 5 and the x. It's 5 lots of x, and x is 4, so I've got 5 lots of 4. Does it equal 20? Yes, it does. Excellent. I can move on to the next question. Okay, this is a tricky one. This time I haven't got 5x. I've got negative x equals 20. What am I going to do with this one? That looks a little bit more challenging, doesn't it? Negative x equals 20. I need to multiply by both sides. Well, there's 2 different ways of doing it. The easiest way to do it is if I've got a negative x and I multiply it by -1, I can remember from my negative numbers that negative multiplied by a negative gives me a positive. So if I multiply this by -1, that's going to give me a positive x. I know that 20 multiplied by -1 gives me -20. So my answer is -20. There is another way of doing it. Okay, I can say I've got a negative x equals 20. I could add, it's a bit hard. Well, let's try. I'm going to add x to both sides, but you're going to have to understand that if I've got a negative x and I'm adding x, I'm now going to have 0 on the left-hand side. And on my right-hand side, I'm now going to have 20 plus x. Remember, I want the x on its own. I want to isolate the x. So I need to subtract 20 from both sides. And that's going to give me -20 equals x. X equals negative. Sorry, you can't quite see that, can you? x equals negative 20. Okay, again, you check by substitution, remembering your negative numbers. Okay, negative 20 is positive 20. So I know I've got it correct. All right, question 6. Make sure you can see. Okay, question 6. We have x divided by 5 equals 25. Now, if we were in the classroom, I'd take a vote and I'd give you a choice of solutions. And I would be curious to know if anybody said the answer was 5. That's the most common mistake that someone will make with a question like this. Let's look at it. 1/5 or x divided by 5 is 25. I want the whole amount. So for the whole amount, I need to multiply by 5. X divided by 5 multiplied by 5 gives me just x on the left-hand side, and 25 multiplied by 5 gives me 125. Remember, just because you know that 25 divided by 5 is 5 and it looks like an easy answer, it doesn't mean it's right. We're just going to do our quick check using substitution. We know that our x is 125. 125 divided by 5 gives us 25. We have the correct answer. Excellent, we can move on. Question 7. So, what about if it was the other way round? Let's say I had 28 and this time I was dividing it by x and my answer is 4. Now, some of you again might look at using substitution, using trial and improvement to see what value of x gives you an answer of 4. And some of you might say, well, I know that 28 divided by 7 is 4, so x is 7. And you would be correct. But remember, I need you to use the balancing method. Really important. So I'm going to multiply both sides by x. That gives me 28 equals 4x. Now I can divide both sides by 4. And I know that 7 equals x, or x equals 7. And I can check using substitution. That 28 divided by 7 does indeed give me 4. Perfect. So again, I know that I've got the correct answer. Now, what you might have noticed here, compared to all the other questions we've done so far, everyone, we've just had one step that we've gone through using our balancing method, doing the same to the left-hand side as we do to the right-hand side. This time, we had to do what's called 2 steps. So I'm just going to put in a little title there. Squeeze it in there. Solving 2-step equations. Hopefully you've got enough room to squeeze that in, or write it at the side. Solving 2-step equations. Let's have a look at another one. Remember, there's a reason why I want you to use the balancing method. Because what if, instead of 28 over x equals 4, I'd given you 33 divided by x equals 5. Now, I can't just use substitution and trial and improvement and say, well, what if x was 5? What if x was 6? I'm not going to get a solution that way. So I know that I need to multiply both sides by x, because I want my x to be a numerator. I definitely don't want it to be a denominator here. So I've got 33 equals 5x. And now I can divide both sides by 5. And that will tell me that x equals 33 over 5. Now, if the question asks you to simplify it, well, I cannot simplify it in this case, but I could turn it into a mixed number. 5 goes into 33 6 times, remainder 3. So my answer is 6 3/5. Again, I can check my answer here by substituting it in. And I'm going to, so if I substituted this in fact, I'd probably substitute it in at this point to make it a little bit easier for myself. So let's just write my check over here. I know that 33 equals 5 multiplied by, and I'm going to write it in this improper fraction format here. And I can see straight away that my 5 and my 5 cancel out, and 33 equals 33. Perfect. Let's keep going. So let's carry on with some more examples of two-step equations. So I've got 7 equals 12 subtract x. Now this time, remember we said that if you have a negative x, you can multiply by -1. But in this case, it's much, much easier just to add that x to both sides. So if I add x to both sides, I'm going to have 7 plus x on the left-hand side, and that equals 12. I can then subtract 7 from both sides. On the left-hand side, I now just have x. On my right-hand side, I have 5. Again, let's do a quick check. And I know that 7 equals 12 subtract 5. So I know I've got the right answer. I'm checking all my own work as I go. Question 10. So let's say I had 8x plus 4 equals 36. I want to collect all my numbers together, so I'm going to subtract 4 from both sides. So now on my left hand side, I've just got the number of x. 8 is my coefficient, x is my number. 36 subtract 4 gives me 32. I can then divide by 8 because I don't want to know what 8x is, I just want to know what 1x is. 32 divided by 8, x equals 4. All right, again, just want to get into that habit of always checking. So I've got 8 lots of x. X I know is 4, plus 4 equals 36. 32 plus 4 equals 36. Brilliant. Once again, I've checked my own work and now I've got the right answer. Let's have a look at one where I've got some brackets. Got a couple of different options here, so let's write the question out first. I've got 3 lots of x plus 2 equals 18. So 3 lots of x plus 2 means I've got 1 lot of x plus 2 and another lot of x plus 2 and another lot of x plus 2. So I can expand my single bracket. You may have used the arrow method where you multiply 3 by x and 3 by 2. So we're expanding our bracket. So we've got 3x plus 6 equals 18. Okay, so we've expanded. We now want to subtract 6 from both sides. So we've just got x and its coefficient on the left-hand side. So I've got 3x equals 12. And then dividing both sides by 3. I've got x on the left-hand side, 4 on the right-hand side. Got my answer, but I still want to check it. Using substitution. So I've got 3 lots of x, which is 4, plus 2 equals 18. So 3 lots of 6 does indeed equal 18. I know I've got the right answer. Okay, so this was by expanding first. But we can, it's another way of doing this, by dividing first. So let's write the question out again. 3 lots of x plus 2 equals 18. This time we're going to divide first. So we expanded first. This time we're going to divide first. I'm going to divide both sides by 3. It means I don't have to expand my bracket. It's up to you which method you prefer. I prefer this second method, but I know a lot of people do prefer just to expand it and then to collect like terms. So if x plus 2 equals 4, I can subtract 2 from both sides. X equals 4. And also, how great is that? So not only can we check using substitution, but we can also check by doing our 2 different methods and making sure we get the same answer. All right, we've just got a couple more to go. This one's very similar, but I just want to make sure we're remembering what to do when we have negative numbers. So this time I've got negative 3. X plus 2 equals 18. Doesn't matter which method you use. You can divide first, you can expand first. I'm going to divide first, and I'm going to divide both sides by negative 3. So now I know that on the left-hand side, I've just got x plus 2. And on the right-hand side, I've got 18 divided by negative 3 is going to give me negative 6. I'm going to subtract 2 from both sides now. And that gives me x equals negative 8. I can check using substitution, or I could check by expanding the single bracket. I'm going to check using substitution. So I've got negative 3 lots of negative 8 plus 2 equals 18. So let's have a look. I've got negative 3 multiplied by negative 6. I know that a negative 3 multiplied by a negative 6 will give me a positive 18. Again, I know I've got the correct answer. Right, 2 more questions to go. Question 13. Again, it's quite similar, but this time, instead of multiplying by 3 or negative 3, I'm going to divide by 3. Okay. So the first thing I need to do is get rid of this denominator. So in order to do that, I need to multiply both sides by 3. I now have x plus 2 on the left-hand side, and on the right-hand side, I'm going to have 3 lots of 18, which is 54. I can now simply subtract 2 from both sides. X equals 52. Hopefully you can start to see now why I really want you just to stick to this one method, because as the questions get harder, it becomes much more difficult to use substitution to try and guess the answer using trial and improvement. Again, let's just check that we've got the right answer here. So I've got 52 plus 2 over 3 equals 18, and indeed 54 divided by 3 does give me 18. Okay, so just for the very last question, I just want you to understand what we do if we end up having a variable on both sides. All right, so our last question of the day, we've got a variable on both sides. And the question I'm going to give you is 3x subtract 2 equals x plus 4. So the first thing that we need to do is collect our like terms. Okay, you should be familiar with that from when we looked at simplifying expressions. It doesn't really matter whether I look at the numbers first or x first. I'm going to look at x first, and I'm going to subtract x from both sides so that I've only got x on the left-hand side of my equation. I have 2x subtract 2 equals 4. I now need to add 2 to both sides. Make sure you can still see what I'm doing. I've got 2x now on the left-hand side equals 6. And my final step is to divide both sides by 2. X equals 3. I say it's my final step, but my calculation is never properly complete until I have checked it. So I have 3 lots of 3, subtract 2 equals 3 plus 4. So I've got 9 subtract 2 equals 3 plus 4. 7 equals 7. Fantastic. I've checked all my work. I can go and relax. Thank you very much.